how many people had done Desmos in the past? Who's played with Desmos? Or like, give me a yes if you have and a no if you haven't. Y or N? Y if you're a Desmos aficionado and N if you don't really know what it is. Okay. Oh, let's do this. We should do this. Okay. I want to try this out anyway to see what people think of it. Desmos is really good fun, and this is an activity that will help you to get used to Desmos and start using it because it's a good tool to have at your disposal. But this is also really good for getting familiar with equations of curves and things. So I'll just we'll come back to the Snoopy project in a minute. I'm just going to start with a new blank graph. So what you can do now, if you've got a computer handy, if you just open a web browser and go to desmos.com, so you don't have to type the calculator bit on the end there, but you can do. Because if you just type desmos.com and then click on the first link that comes up, then you'll get straight to the calculator anyway. Okay. And what we're going to do is just try doing some graphs. Okay, so to start off with, all you have to do is type in like y equals x squared, like that. And how do you get that squared thing there? Well, the trick is if you press Shift 6, I must have caps lock. Let's try again. So if I want to do cubic, then I press Shift 6 to get that up arrow, and that allows you to get the power, and then we can do that. Okay. And then, oh, why don't we just carry on doing this actually? Y equals x to the power of 4. Y equals x to the power of 5. Y equals x to the power of 6. Okay. So hopefully you're all getting something like this. Is this working for people? Now, shout at me in the chat if you can't get it to work, because I'm just assuming that you're all right with this and it's just working. And it is a really good idea if you're rather than sit and watch, if you can actually play with it. By the way, you can do this actually even on the web browser on your phone. This actually works fairly well. They do have an app as well that you can download, but I found it's really glitchy, so I've deleted it from my phone because actually the web version is absolutely fine. Right, a few things that you can do. If you click on this this cog here, edit list, like that, then you can change the colors and the thickness of the line. So this one here, let's suppose I want it a different color. Maybe I want it as a dotted line. Maybe I want the dots to be bigger, like that. I can do that. Let's change the color. I'm not sure what that one does actually. No, I can't figure it out. Oh, opacity. Oh, it's like, yeah, how opaque it is. Right, so if we try 1, then it's solid. And if I try 0.5, then it goes faint. Oh, I've never played with that before. Oh, that's pretty neat, actually. Right, okay. So, and then you can click on these dots and you can change any of them that you want to, like that. Okay, so that's one thing that you can do. You can also switch them on and off, which is sometimes quite handy. And then for what we're going to do with drawing Snoopy, here's a really important thing that you can do. If you change y into, and I'm going to put it in brackets here, which will make more sense later probably, change y into y minus 3, then suddenly it disappears. And actually it's not disappeared, it's just moved up. And you notice it's moved up 3 places when I change it to y minus 3. Right, now, any guesses what will happen if I change x into x minus 1? Right, answers in the chat. If I change that x there into x minus 1 instead of x, will the graph move up 1 place, down 1 place, right 1 place, or left 1 place? So Neeb's saying up 1, Chris is saying left 1, Losco's saying 1 forward, somebody's saying it'll move right, Patrick's saying it'll move right, Eleanor's saying left, Ben's saying move right, Lavinia right on X, Charlie's saying it goes right. Jacob's saying it goes down one place. Emma's saying it moves right. Vivian's saying right. Lucy's saying right. Chris is saying right. So there are some people who've covered this in lessons, I think, and some who haven't, because the people who are saying right are correct. Now, let me just change these things here for an A and a B. And then when it says add slider, I'm going to click all. And you'll notice what's happened here is it's defaulted to A equals 1 and B equals 1. And then I can change the value of A, and that lifts it up. And obviously I can change the value of B, and that moves it right and left. And that is actually a really important little tiny bit of mathematics. If you've got an equation, even if it's quite a complicated equation, and you substitute, instead of y, you put y minus a in, then it will always move up by whatever value a is compared to how it was before when it just had a y. And if you make a negative, so you get y, in this case, this is now y minus minus 1, which is really y plus 1, that actually moves it down one place. So it's actually pretty cool, this, isn't it? So if we were to go with, let me show you a more interesting graph. Actually, I won't make it too complicated. If I did x squared plus y squared equals r squared, how many people can tell me in the chat what shape is going to appear next? Some of you will have done it before. Well done, Vivian. That's right. Lucy, yes. That's right, Chris. That's right, Charlie. Tabitha. How many people have not seen this equation before? Well done, Jacob, James, Abby. Not quite right, Roscoe, but that's a very clever comment, actually. We'll come back to that. Well done, Lily. Right, so useful to note. Yeah, so quite a few people have not seen this before. And you probably should have seen it by now if you're in year 11. If you're in year 10, you might not have done. If you're in year 11 and you've not seen it, we can probably blame COVID for that and all the disruption. So this is actually, if I now add r in as a slider, this is actually the equation of the circle. And if I change the value of r, you can probably guess why I've chosen the letter r for that number. Because what quantity does r describe in that circle? What property of the circle is it? That's it, Lavinia. Yeah, well done. Oh, too many people. I can't respond. Yeah, lots and lots of people. It's the radius of the circle. Now, somebody earlier on, can't remember who it was, said it's a right angled triangle. And I said, oh, not quite right, but that's a really interesting comment. And in fact, they were right in a way. Now, I really want to be able to write on the screen. I don't think Desmos will let me do that. But if you start by drawing a radius in, let's see if I can I just add a point somewhere? There's a way of doing this, I'm sure. Can't think what it is. Oh, I know what it is. If I put in 3, 4, if I just type a coordinate, that's it, then I can get a point. And you can see that point there, 3, 4. Well, we all know about the Pythagorean triple 3, 4, 5, hopefully. So you know that 3 squared plus 4 squared equals 5 squared, because 3 squared is 9, 4 squared is 16, and 5 squared is 25. 9 add 16 equals 25. And because in this circle, that was actually 5 r, if I put 3 in for the x and 4 in for the y, then that has to lie on the circle. I'm just going to change that back to r there so I can fiddle more with it. So if you draw a right angled triangle, which is, let's say, when x equals 3. Ooh, now, here's an interesting thing. This is going to be really useful when we're trying to draw Snoopy or something like that in a minute. If you put some squiggly brackets in like that, which is near the return, the enter key on your keyboard, if you press shift square bracket, you get squiggly bracket. If I want that line to be restricted so that I only want the bit between the x-axis and the circle, then I can say I want the y value to be greater than 0 and less than 4, and then it will restrict the domain of that function so that it only shows me the bit where the y coordinates between 0 and 4. And that is a particularly useful thing when you want to draw pictures of snoopies and other things along those lines. Now, if I also draw in, how am I going to get a line from 0, 0 to 3, 4? I can't think of why I do actually. Let's label the origin. I can do that. Let me just add in that line. What I might be able to do is say theta equals don't worry about what this means, by the way, because this is getting a bit too advanced. Oh no, it doesn't know how to do polar. Yeah, it's not clever enough to do that yet. Right, okay. So anyway, there is a right angle triangle there, which is what somebody, who was it who told me that? Somebody told me it was a right angle triangle. Oh, it was Losco. Right, well done, Losco. Okay, so we've got that there. Now, the reason that I started drawing a circle, because I wanted a more interesting curve than those other ones we drew. If I now get this circle here, I'm going to go back and just fiddle around. Let me just turn those other things off for a minute. I'm going to change that x so that it's now x minus a squared, which is a bit different to what I was doing before, actually, because I think I had the b with the x, didn't I? But never mind. I'll do x minus a and y minus b. Oops, I didn't want that squared. Still, let's get rid of that. I want the squared outside there. And you'll notice that the circle is no longer where it used to be, but I can bring it back. If I make b back equal to 0 and that equal to that, then it's back where it was. And if I want that circle to move across a little bit, then I can do that. Oh, sorry, that's not across, that's up. Get a grip, Haigh. Across is moving that way because it was the a that I'd put with the x. So that's moving it across. Notice this was minus a, that's an important thing there. So as I increase a, it moves across. And you can figure out why this is with a little bit of thinking about why would it be that subtracting a has the effect of moving it to the right. Well, if I just let a equal 1, just for the sake of argument, right? Imagine that I am a little munchkin who lives at the point 1, 0. That is my home. This is where I live. My only purpose in life is to help Desmos draw equations. And what I have to do is I wait until somebody comes along with an equation, and then I think about what my role is in that equation. Well, my x value is 1. So I think about this, I go, right, okay, well, my x value is 1. So I go 1, because that's me, minus, well, that a happened to be a 1. So 1 minus 1 is 0. Okay, right, so that is now 0, I'm thinking. And then I've got y minus the b. Well, the b was actually a 0, so let's just to get rid of that, just say that. So now I can see in my munchkin life that y squared must equal r squared. As it happens, r was 5. Let's put 5 in to make that more obvious. So now as in my little munchkin math head, I'm thinking, right, well, if this bit is 0, then that's just 0, and y squared equals 5, so y must equal 5. So what I do, this is my mission in life, I now change my y value to be that, and I know that that is where I should be. So before I did any maths, before I did any sort of working out the y, I had to first of all subtract that 1 from myself. Now, if I didn't have to subtract that 1, if that had actually been a 0, then it would look like this, and then the munchkin who lives at 1 would have been thinking, right, okay, 1 squared add y squared equals 25. Therefore, y squared equals 25 minus 1, which is 24. So it must be that I have to go to the square root of, by the way you get a square root of Desmos is you type sqrt, square root of 24, and then that's what I suspect that me talking about munchkins is no help whatsoever, but that is just a weird and twisted way that I think about it. I just imagine that there are all these little guys, little pixels, maybe they're girl pixels, living on that axis, and they're trying to work out what their y coordinate ought to be. Yeah, that probably made no sense at all. Anyway, right, let's go back to Snoopy. So what I'm doing with my Snoopy project, and you can do the same thing. So basically what you do is you get a picture of the thing that you want to draw, and you save it onto your hard drive, and then you go plus add item, and you go image, and then, oh, look, I'll find some more images. We could do an image picture of me, or better than that, we could do Hannah Fry. Right, so there's a picture of Hannah Fry. This is actually, believe it or not, probably won't believe this. This is Hannah Fry holding up a picture of our Victorian maths textbook. And do you know why she's holding a picture of that textbook up? Does anybody know? That is our Hall and Knight elementary algebra. And the reason that does anybody watch Have I Got News for You on TV? Looks like nobody does, because nobody's saying anything in the chat. Maybe it's because you're all just working on Desmos. She did, yeah. She actually talked about it last year. So she actually mentioned that some head teacher somewhere was teaching these students using a Victorian maths textbook, and it was me that she was talking about. And so I got the mickey taken out of me, and Have I Got News for You? And then she read some stuff out of the textbook, which I don't think was even in it, certainly not in my version of it. Yeah, anyway, so you get your image and you can put it in there. We'll just get rid of Hannah now because she's actually a bit too difficult to draw, whereas Snoopy's quite easy to draw. What you can then do is you can switch the Snoopy on and off by just clicking on the image there like that. And then you can map curves and move them around to fill in the gaps, okay? So let's suppose I want to do a bit of his collar here. And so I'm thinking, right, well, actually, his collar, really, I could just do it with maybe a straight line. So I could say, well, it's a straight line with a little bit of a gradient on it, maybe 1.2x, something like that. Oh, no, that's much too steep. Oh, actually, what am I talking about? It should be that the gradient should be near 0, shouldn't it? So 4.1x. Oh, that's about right. So the problem with that, of course, is that it's in the wrong place. So what I need to do is I need to move it down someplace. So I'm going to go y minus minus 1, which is really, should just y plus 1. Oh, that's too far. Y plus 0.4. Oh, that's pretty good. Now I think, oh, I'm going to just adjust it and make it very slightly steeper. That's it. That's slightly better. And now my problem is that it's actually going all the way both sides. So what I'm going to do now is I'm going to restrict it so that the x value is between 0 and 1. It's about the right length now, so that's better. Now my problem is that it's the wrong color. So I'm going to click on the settings. I'm going to change the color to black. That's slightly better. I'm going to make it thicker. Right, now that is a lot better, but it's now, because I made it thicker, it's sticking out too much. So I'm going to restrict it some more to like 0.8 and 0.2. And then I can, if I switch Snoopy on and off, I can get an idea of whether I've got it right. Yeah, that's not bad. That's pretty good. Okay. How's this working for people? Do you like this? Can you do it? Okay, is anybody getting any problems? Is there anything you can't figure out how to do whilst you're trying it out? I'm assuming that you're all giving it a go. Yeah, it's a good puzzle. Yeah, and this is actually, it's not just a waste of time like a lot of things that I do on my computer, Call of Duty, Age of Empires, things like that. It's actually mathematically really worthwhile, because if you do this and spend an hour or two working it out, then you'll actually internalize quite a lot of really good mathematics. So you might not necessarily develop a really clever understanding of everything, but lots of things will become quite automatic so that other stuff becomes easier. Now, what you might need is more of a repertoire of nice curves that you can use. So I wonder if I could just show you a few more neat curves that might be useful. So I've shown you the circle. You can make a circle into an ellipse, which is like a sort of flattened or stretched circle by doing this. So if I go x squared divided by, I'm going to have to use, what letter shall I use? D squared. I'll add a slider for that. Plus y squared divided by e squared, make that equal to 1, then what you get is an ellipse. And then, oh, right, now that e is problematic because e can't represent just any number. It has, there's a particular number that e is always e, a little bit like pi is always pi. E is a special number in that. So I'm going to change that to f, and then it'll let me have a slider. Okay, so now it looks more like a circle because f is 1 and d is 1. But if I want to stretch that out, I can do. And if I want to stretch it out the other way, then I change that value there. So this will allow you to get a bit more curvature, like a wider range of curvature. But of course, I want to be able to move that up and down. So I'm going to substitute for x. Any guesses what I'm going to substitute for x? I'm going to do x minus a. And I'm going to do y minus b, like that. And then I can just grab my b's and my a's, and I can move everything around until it's just where I want it to be, like that. And I can change the shape, that sort of thing. And then when I've got something that is roughly what I want, then I can restrict it. So put it in my squiggly brackets and say, right, okay, I want that to be from x equals 2 to x equals, now this is really useful, actually. My problem here is if I try and restrict this, even if I'm really clever and I say, oh, I'll go from that to 3.2, like that, I still end up with that bottom bit that's over his ear. Well, I suppose I could just say, well, I'm not going to worry about that because I want that bit of his ear to be there anyway. But here's what you do in Desmos if you want to restrict that. And you can add another condition as well. So here's this condition is going to be, and the y must be greater than 3. And that then, by adding the condition that the x coordinate has got to be between 2 and 3.2 and the y coordinate must be greater than 3, then I lose that bottom bit there. Okay, now what I'm going to do is I'm going to make that permanent now. So that b, I'm going to change it to a 3. And that f, I'm going to change it to a 2.1. And all right, what else did I have here? I had an a, that was 0.4, and I had a d, that was 3. And so now I can change my sliders. It's not going to move anything around. So one thing left to do, I just have to change the color. So click on that, click on that, make it a bit thicker, maybe change the opacity. Otherwise, yeah, that's right. Actually, if I want to really match it, 0.9, something like that, I can turn Snoopy on and off. Oh, right, like that. Yeah, I'm getting somewhere with that now. Okay. Right, now, would you like me to just leave it there and just let you get on with it? Or would you like me to show you some more curves that you might be able to use? Answers in the chat box now. Shall I shut up and let you play, or shall I show you more curves to play with? Amy's voting for more curves. Okay, Losco wants more curves. Right, okay, more curves. Right, okay. In that case, I'm going to copy this one here. I love this reaction. There's lots of messages in the chat going, more, give us more. That's fantastic. So let's change this. I'll get rid of that bit there. And I'm going to change that, make that B again, and make that A again. And I'm going to make that D, and I'm going to make that F. So this was the ellipse that we had before. You can see it's just appeared in blue there. Let me just move it down a bit, actually, like that. Okay, so move it there. Now, what I'm going to do is I'm going to switch this. By the way, do you know, when I was thinking about whether I should do this activity with you guys, I thought, well, will they see the point of it? Will they just think, well, how's that going to help us with our exams? And I thought, actually, this is a brilliant way of showing your maths teacher what an utter, true genius geek you are. And that is actually a really good strategy, particularly for year 11 students at the moment, because at some point in the next 6 months, your maths teacher is going to have to decide how smart they think you are in order to give you a GCSE grade. I mean, obviously, they're going to have to do exams and things like that when you go back to school. But if you happen to show them a genius picture of Snoopy or something like that, where you've used loads of really clever maths that they haven't taught you, then they're going to feel obliged to give you a really high grade, aren't they? So here is a really clever bit of maths that actually students who do A-level maths don't even get onto this. You only learn this if you do further maths. So if we just switch that plus there for a minus, then you get this curve here, and that is called a hyperbola, spelled hyperbola, like that. And so we can just do the same things that we did before. We can change the value of D to squidge it in and out. We can change the value of, you know, this might actually be quite a nice one for doing his neck with. So if we, let's try and, oh yeah, that looks all right. And then like that, move that across. Oh, that's not quite right now. Move it down a bit. Oh, that's good. Yeah, so that just does that section there to about there. So if I now restrict that for the range, let's see, x is less than 0 to x is minus 2, something like that. Oh, sorry, I don't mean x, I mean y. I'm talking about, right, like that. And then I don't want this bit over on the left here, so I'd better add in extra conditions, a new set of squiggly brackets, x greater than 0. Now I've just got that. Right, we're nearly there now, so all I need to do is just change the color of it. So like that. Let's make it more opaque. Well, let's make that a bit thicker. Oh, that's a bit too thick, actually. 7's more like it. Okay, so right, so that was a hyperbola, and that's basically the same equation as an ellipse, but with a minus in front of it. And just talking some proper maths for a minute, these curves, parabola, hyperbola, circle, and ellipse, are all actually, believe it or not, the same family of curves, come from a family of curves called the conic sections. So they can all be made by, if you start with a cone and you just cut straight through a cone, then if you cut straight across, then you'll get a circle. If you cut on a bit of a slant, then you'll get an ellipse. If you cut parallel with the side of the cone, like if this is the cone and you cut parallel with that side there like that, then you'll get a parabola. And if you cut steeper than that, then you get a hyperbola, which is why when I first drew my parabola, let me just create a new parabola. can you see that there are actually two sides to it? It's called the two naps of the curve. And that's because the cone that we're talking about, let me just show you a picture of the conic. That's a nice picture there. This thing here. So we get, you get a circle if you cut straight across, you get an ellipse if you cut on a tilt, a parabola if you cut parallel to the side, and you get hyperbolas if you cut more steeply than that. And so there's some really nice maths about this that you do in further maths A level. So there we go, there's that. What other nice curves do you know about? You know about the reciprocal graph. This, by the way, y equals 1 over x. So that's a graph that you may have covered in GCSE. You should know the shape of that. And obviously, we can change that value on the top. Let's call that G, and we'll add a slider for that. So we can squidge it in and out like that, make it bendy, less bendy. And then, of course, we can do the same trick with that we did with the other ones, where we can have y minus a, x, oh, hang on, x minus a and y minus b. I need to make my mind up about this. Let's make that b there. Okay, so now I can move that around. Oh, that's ruining my neckline there, actually, for Snoopy. So what I needed to do with that neckline there was I needed to just get rid of that. I needed to make that into plus 1.7 and that D, fix it as numbers, and then I can move my sliders around without messing it up. 2.2 B minus 0.2, so plus 0.2 there, like that. Okay, so now hopefully I can move things around now, and it's not ruining that little bit of work that I did around his neck. So I can move those things around there. Yeah, it's pretty cool, isn't it? It's good fun. Okay, so other ones, of course, you already know about y equals sine of x. So you can use y equals sine x. You can use y equals cos of x, like that. You can, now I wonder if it can cope with this. R equals 3. Yes, it can. Right. Okay, so this is getting a bit clever now. This is called polar coordinates. Polar coordinates are a way of specifying space, describing space without using x and y coordinates. So instead of saying how far across to go and how far up to go, which is what we do with Cartesian coordinates, polar coordinates tell you what the radius should be. So I could go, probably this needs a completely different lesson actually to really go into this, but yes, distance and angle, that's right, r and theta. So radius is how far from the center, and theta is the angle relative to the starting line. So if I said r equals theta, then you get a spiral. And the reason for this is we always start out by pointing along the positive x-axis, and that's where the angle is 0. And then as the angle increases, the distance from the origin increases. So when the angle is 0, the distance from the origin is 0. When the angle is this angle here, so pointing from the origin towards this point here, it's a slightly bigger angle, so it's a slightly bigger distance. And then we've got this one here, that's now 90 degrees. It'll actually be done in radians, so it's pi by 2. But we've never talked about radians, so you don't know about that. So yeah, that's perhaps one for another day. I think we don't need that complication just yet, but you can do polar coordinates when it gets to that. But you don't need that to draw Snoopy. You've got enough, just even if all you had was circles, ellipses, and parabolas, and straight lines, you could do a pretty amazing job of it, actually. Okay. Right, so bang goes any other interesting maths that basically, I reckon all maths homework now is boring until you've spent a few hours playing with this, because this is so much fun. So your maths teacher may not thank me for it, but there we go. So I think we'll leave it there, folks. I reckon it would be really nice to see what you can create. I mean, if you want to play with Snoopy, that's great. I think that picture of Snoopy I just got off Wikipedia or something and just downloaded it and then saved onto my hard drive and then put it in Desmos from there. But you could, any cartoon is going to work quite well. Obviously, the more complicated it is, the more difficult it is. If you want to send us what you've done, you could email it to me, or you could put it in the classroom, or you could, I mean, some people wouldn't want to do this, I suppose, but you could put it on Instagram or Facebook or whatever and tag us in. That would be pretty good. We've had people do that before. I reckon there ought to be prizes for this. Would you like prizes for doing a good job? I reckon I can probably come up with something. We can do, we've got goodie bags. I'm trying to think what goodies we've got. I mean, they're not very exciting goodies. We've got pens, notepads, we've got shoulder bags, we've got water bottles. Oh, we've got some nice little hardback notebooks. So we could do some good stuff like that.